This is the third section of notes for work and energy. To begin with, we're going to say that work actually changes mechanical energy. And what do we mean by that? Well, basically what we mean is if we apply a force, we do positive work on a system, and that tries to increase the amount of energy that we have in that system. If an applied force does negative work, it tries to decrease the amount of mechanical energy that we have. The two forms of mechanical energy are called potential and kinetic energy, and we will do some things with those two types of energy. Before we go on to that, let's kind of look at a little bit more about work. We know that Jane uses a vine wrapped around a pulley to lift a 70-kilogram Tarzan to a treehouse about 9 meters above the ground. So what we're going to do is we're going to look at how work affects the energy in this system. They want to know how much work does Jane do when she lifts Tarzan. Let's draw a free body diagram of the system. So here we can say that this is Tarzan himself, and we're going to lift him up, and we know that there is a force of gravity that opposes the force of Jane trying to lift Tarzan. We also know that we are displacing him in the same direction, so we say that the change in distance or displacement here is 9.0 meters. Our equation for the work that Jane does is equal to F times the change in R times the cosine of the angle between F and R themselves. That is equal to M times G times the change in R times the cosine of the angle. And now we can put in for the mass that she lifts, that would be Tarzan, so that's 70 kilograms, times gravity, which is approximately 10 meters per second squared. The distance or the displacement is 9.0 meters, and we can multiply that times the cosine of, and remember this is going to be 0 degrees. If it's 0 degrees, then that number would be 1. And if you do all that, you end up with 6,300 joules. So she increased the energy, so we say that that's positive. How much work does gravity do when Jane lifts Tarzan? So that's going in the opposite direction. We know that this is our delta R, and we know gravity actually acts in the opposite direction. So we see that this angle is approximately 180 degrees. So we say that the work gravity does would be equal to that same expression. It would be 70 kilograms times 10 times 9 meters, but now we're going to take that times the cosine of 180. We know that this is really -1, and so we see that the work gravity does is -6,300 joules. And that is the first part of that example problem. In the next section, we'll look at the next example problem.